Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will be able to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience, so if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll take a few minutes near the end of today's webinar and go through those audience questions. And also near the end of today's webinar, we will be doing a drawing for 3 $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our 3 lucky winners. All right, with that, we will kick off today's webinar, which is fire alarms versus fire hoses, keeping up with dependencies. Our speaker today is Rhys Arkins, who is Director of Product Management at WhiteSource. Hi, Rhys, how are you? Thanks for joining me today.
Hi, thanks.
Awesome. Okay, well, I'm going to go ahead and put myself on mute, let you get right into your presentation.
All right, thanks very much. Well, good morning to everybody over in the US, and good evening to anyone joining from Europe. So we're talking about dependency management today, with a particular focus on an approach for risk management with vulnerabilities. Okay, so part one, to get people on the same page, discuss dependency management for a little bit, the different approaches people have, in particular to including open source components within their software projects. Part two will be the vulnerabilities challenge. It's unlikely that you've managed to avoid any of the news or alerts in the past few years about vulnerabilities in open source. So I'll be talking about the different ways that people manage that today. And then to finish off, talk a little bit about where we see the future going and how we can make things, well, how things will be better for everybody, we think, in the future. All right, so the first part, just like I said, to get everybody on the same page, we'll talk about dependency management and how it's matured and what the current state of play is. All right, so the old school approach to dependencies, the very earliest kind of use of open source was essentially you would find useful libraries or code. So code that you could use in your project that others gave a license that you could use. You'd copy and paste it into your project, and then essentially you'd move on. So this was kind of like, you could think of this as like the Stack Overflow early approach, where you find code that's useful, copy it into your project, and that's it. It works, and you probably forget about it. You may even forget where you got the code from. Now, this matured a little bit because people started using a lot of third-party code, and so the CDN approach became popular, and it's still very popular and a good approach today for many. So in this case, you'll generally find some third-party code, especially JavaScript or CSS. You'll locate a CDN that hosts it. So it could be like a Google CDN, it could be CDN.js from Cloudflare. You'll find somewhere that's hosted, and you'll then copy and paste a link into your website headers, and then everyone who's browsing your website can download these third-party components from the CDNs. And this works fairly well, especially for people who want to speed things up by having it downloaded off very fast sites. And again, for most people, they then move on from this. So Cloudflare, for example, did a study recently that showed that the majority of users of JavaScript and CSS on CDN never update the version. They put a version into their headers, and it takes a very long amount of time for the amount of people using each version to decrease. So even though when new versions come out, they see a lot of people using them, those are not often people transitioning from the old versions. So these first two approaches both suffered from the same problem, that people put code into their software, especially their websites, and then forget about it. Now, the third approach, which I'm calling early package management, this is really the current state of play for things like JavaScript with npm or Ruby with Ruby gems and so on. So in this case, there'll usually be a concept of a registry. You'll browse a registry, you'll select a package. So it's a little bit different. You might even be searching the registry for certain keywords you want. You will normally add the dependency to a package file. So it could be a package.json, it could be a gem file, it could be a Go modules file these days. And in the early package management, the most common way was that you would stay always up to date, because every time you installed, you'd get the newest version. So people would say, okay, I'm going to use, version 2 of Lodash. And it meant that every time you installed, you'd get whatever the latest version 2 was. Now, this had a pretty serious downside. We refer to this as dependency roulette. Now, whenever you always install the latest version, it might mean that team members might run different versions. And it usually does work, because usually versions are backwards compatible, but sometimes it doesn't. And especially if you're involved in web development, say 3 to 5 years back, it was pretty common that you would have times where you needed to ask your colleague to work out what version they were using because it worked on their machine and it didn't work on yours. So this early approach to package management, although it seemed like a good idea to stay up to date by just always installing the latest, it didn't work very well, especially because it wasn't very controllable. You wouldn't necessarily know you were using a different version from anybody else. It may not even be very easy for you to determine what version you were using. So moving on to modern package management, and this is where I would say mature projects are today, is that you would declare the dependencies using package files like you did previously in the early package management that I mentioned. But the difference these days is the use of lock files. And what lock files give you is essentially reproducibility. When you have a lock file, it means that not only your direct dependencies, but even your indirect dependencies, they're the friends of friends that the dependencies you use bring along into your project. Those are locked. Now, another good way of thinking about lock files is that they're frozen, that you're essentially freezing in place your use of third-party dependencies. And this is good because you get the same results every installation. This also means that the works on my machine problem is greatly diminished, and ideally you wouldn't even have that problem from a dependency point of view, because you and your colleagues, if you're using the same branch or commit, will have the exact same dependencies installed. And when you push it to test and then push it to production, again, you'll get the exact same versions. The challenge with this, though, is that you have frozen it in place. It doesn't anymore move on. So at the time, if you installed version 1.4.3, if you never updated deliberately, you'd still be on 1.4.3, maybe 12 months later, for example. You wouldn't be automatically updated to anything. So it's essentially a double-edged sword in that you don't get accidental upgrades that might break you, but at the same time, you don't get free upgrades that just keep you automatically up to date. So this brings us to the challenge with vulnerabilities. So vulnerabilities are on the rise. There's really two main drivers of this. The first is that there are more people than ever looking for vulnerabilities in open source. So people, especially you might call it the white hat researchers, professional security researchers, are spending a lot more time looking for common mistakes in open source software, and they are reporting them. But secondly, there is of course a great increase just in the use of open source as well. There's more packages, there's more versions. So if you multiply together the increased amount of open source with an increasing interest in finding dependencies in open source, you understandably get a graph like you're seeing now, where the number of vulnerabilities are rising. So as a software developer or a DevOps professional, this then becomes part of your problem. All right. So the way that vulnerability alert services work, and white source is one of these, of course, is that they will scan your source code regularly. So it could be per commit, it could be intelligent, so it knows which files are related to dependencies and which are not. But it'll scan your source code regularly enough to detect all third-party code within your software projects. And this is this term dependencies. The next step is that it will then cross-reference or cross-match that against a database of known vulnerabilities. So it's important, of course, the detection, but also it's important the coverage of known vulnerabilities. Now, if and when you do have a match, these services will then notify you and your team of any new vulnerability. They may ideally include expert advice on how to fix it. So describing to you how to fix the problem, not just the problem. And if you're really lucky, you might get a pull request as well to even give you like a one-click ability to remediate that problem. Right, so this is vulnerability services, and probably a lot of you have had experience with these types of alerts, especially in the last 1 to 2 years. Now, here is the challenge though. This is the first part of the subject of the presentation. We call it the fire alarm approach. So the fire alarm approach is where you basically don't do anything with your dependencies until you are notified of a vulnerability. So that notification, this is the fire alarm. Now, the problem with this is that the vulnerability might be an extremely important vulnerability. It might be, classified as critical. It might be exploitable within your web application. You have no choice but to, to get rid of it, right? Your company might rely on you to get rid of the vulnerability immediately. So essentially, you're at work one day, you get told, we've been alerted that there's a vulnerability, we need it out immediately, or maybe we need to shut down the website, shut down our app or something like that. Now, where this becomes a big problem is if you happen to be, 18 months and 10 releases out of date. And this is what tends to happen if you take the fire alarm approach to vulnerability management, where you leave your dependencies as they are until there's a need to change them. If it ain't broke, don't fix it. Because the problem is, if it is broke, you've got a lot of work to do. So as the graphic here shows, you've got a choice. You either can remain vulnerable for as long as it takes you to make a decision, or you can maybe upgrade those 10 releases without adequate testing. Normally if you had, an old dependency that has released a lot of minor differences in the last year or two, you'd want a fair bit of time to test that. But if you're being told that there's a critical dependency and it has to be done now, you're stuck between a rock and a hard place. Either remain vulnerable or to upgrade. Okay, so pretty much every developer who's ever faced this challenge where you need to get rid of a vulnerability, but at the same time, this is not going to be easy. Pretty much every developer in that situation has always wished to themselves, I wish this was just a patch, right? If this was just a 1-line patch, a 5-line patch, if it was just a single release even, this would be so much easier than the 10 releases that I'm now faced with. And yeah. All right. So at the next step, we look at dependency automation as an alternative approach. And actually, one thing it's important to point out with the previous scenario of I wish it was just a patch is that mostly what we're talking about here is vulnerabilities in open source. And in this case, you don't have generally any type of support agreement. You don't have backporting of fixes, especially not if you are 12 or 18 months out of date. In that case, the person who is fixing the problem in the open source package is very unlikely to be fixing it in every single minor release for the past 18 months. The most common scenario in open source is that vulnerabilities are only patched in the very latest version. So then the responsibility is on you as the open source user to upgrade to that latest version. So as a different approach to dependency management, so different to the if it ain't broke, don't fix it approach, we now talk about dependency automation. So this is also like a recent statement, but typically if you're using Windows or Mac, and if you're using Android or iOS, then your computer and phone generally keep themselves automatically up to date. So once upon a time, there used to be the scenario where people would say, make sure to check for updates, make sure to apply the patches. But in general, what we see today is that these patches and updates are given to you automatically. And in general, you don't have to do too much. Like I personally don't have too much of a concern about vulnerabilities on my phone because my phone gets automatically updated when that happens. So the question therefore is, if your computer and your phone are keeping themselves up to date, why can't your software project? You know, if you're a professional DevOps or software professional, why isn't what you spend 40 hours a week on, why doesn't it have the capability to be automatically updated? Why is this a manual task? So the way that dependency automation tools work is that, again, they scan your software project for dependency declarations. So they are looking not for copy and pasted code, but they're looking for declarations where you have, say, npm or yarn for your JavaScript, for any of your npm modules. You've got bundler for Ruby, poetry or pipenv for Python, and so on. So they're looking for explicit declarations of dependencies. These can even be in Docker files, for example. They check if there are updated versions existing. So if you're on, version 1.2, then they'll let you know, they'll look and see if there's, version 1.2.1 or version 1.3, or even potentially versions 2 and 3 made with major updates. The next step, once they have detected everything in your software, or ideally detected everything, they will check if updated versions exist. They will submit pull requests, ideally including release notes, so that you don't have to go and look those up manually. And then they'll support grouping and scheduling according to your preference. So if you say, I want to get updates, on weekends, or I want them only on weeknights when we're not developing, that's the type of thing that you can control. So this is known as dependency automation, and what it does is saves you from A, having to remember to update dependencies, but B, it's also saving you from a lot of the manual work that really should not be part of your core role or your core product. And so this approach, though, I've coined as fire hoses. In honor of the fact of the many videos and GIFs we see where, massive fire hoses with a non-stop stream of water, because even though dependency automation is a great step forward, it does come with its own work as well. So on the good side, being relatively up to date with dependencies, it significantly reduces the time and the risk of remediating vulnerable dependencies. So in the scenario we had earlier, where there was, an 18-month out-of-date dependency with 10 minor releases, and even then I was being polite because you're often going to have major releases with breaking changes if you wait that long. Now, in that scenario, if you compare it instead to if you had an automated approach where you, say, applied updates every month, 2 weeks, a week, that type of approach. So you're not perfectly up to date, but you're relatively up to date. Even then, when you get hit with a vulnerability, the time it takes you to remove that vulnerability and the risk of you having to make this quick decision, these are greatly decreased. So even if you view that your main concern is vulnerabilities, not just updates, being updated is itself a very positive approach to vulnerabilities, because the risk of the vulnerabilities will be greatly decreased. Now, another interesting point is that staying up to date might even mean patching vulnerabilities before they're even announced. Now, this might sound, a little bit hard to believe, perhaps, but let me explain. If you think about the way vulnerabilities in open source software, or any software, in fact, should work, is that it's nearly always the case, and it's definitely the ideal case, that at the time when a vulnerability is announced, or we call it, disclosed. So at the time when it is disclosed, and if it is a really bad one, you might read about it on devops.com or the register or something. So at the time when it is disclosed, you really want to have a fix already. I mean, it's a worst case scenario when a vulnerability gets announced and there's no fix available. Then you're just vulnerable with nothing you can do about it. It does happen occasionally, but it's pretty rare. So if you think about it, what that means is that, fundamentally speaking, patches, like fixes for vulnerabilities, are prepared ahead of time compared to when the actual vulnerability is announced. Now, this might be, in some cases it might be released simultaneously, but in most cases, most projects don't need to do that type of exact releasing and announcing at the same time. What you often see, and we're working on a study of this right now to try and quantify this, what you often see is that vulnerability fixes are issued discreetly, days or even weeks ahead of time. So someone realizes that there is a memory buffer overflow exploit, or there might be an SQL injection or something like that. So what you'll often see is just a very simple patch that says fixed memory problem or updated SQL. So unless someone was watching very closely, they wouldn't realize that this was a vulnerability patch. And that might get published and released, like I said, hours, days, even weeks before the official announcement, with a full description of the impact and what people should do becomes released. Now, what that means is that if you have an automated system for, raising pull requests when new versions are available, and if you are pretty diligent at applying patches, especially simple patches such as fixed SQL statement or fixed memory bug, then it's actually very possible that you will end up patching vulnerabilities before the vulnerabilities themselves are announced. So if you've ever felt like you get too many vulnerability notifications, well, you'll decrease them a lot if you actually were already ahead of the vulnerability before it was announced. Now, as a side benefit, bug fixes are an added bonus. So this is dependency automation, but even though I'm describing it in very, nice terms, there really can be a lot of updates in any week or month. And so this is itself a challenge. You've got to, drink from the fire hose, as they say. All right, so if we recap current best practices, if we look at the current best practices for vulnerabilities, first of all, you must absolutely have ability to know what you're using and know if any of those are vulnerable. If you have no process in place, no automation, no scanning to know what you have and then be able to tell you if there is known vulnerabilities, then you are at the highest risk of having problems, of having data breaches, this type of thing. It is definitely best practice to also have a process for managing vulnerability remediation. Merely getting notifications is really just the first step of a maturity model for dealing with vulnerabilities. Having a process, i.e., who is assigned, how is it managed, what do we consider to be, finished? Like a developer might consider it to be finished when they've pushed the code to update the dependency, for example. But if that hasn't been released in an app store, or that hasn't been pushed live by DevOps, then from a company point of view, the problem is definitely not fixed. Now, the third part is ideally to automatically remediate when available. So even with a process to notify you of vulnerabilities, even with a process for managing it, if ultimately it's left to, to humans to manually locate the correct files and manually update them and make sure that they got the problem, this itself is another risk. So the ideal is, never send a human to do a machine's job. So if a machine can provide this automation for you, then ideally do so. So we refer to this as remediation. And so we call a pull request that fixes a vulnerability, we refer to that as a remediation pull request. All right, so that's a current best practice for dealing with vulnerabilities. And so even if, say, your concern is just a security concern, or you're from a security team, this would be the minimum that you should be looking at. Now looking at updates, so automated dependency updates. So the first thing is use an automated tool for processing dependency updates. There's going to be a lot of them. It's maybe not as risk prone if you're just doing updates, but in my opinion, there is no one on a DevOps team or a development team whose time is so low in value that they should be manually applying updates to dependencies. There's really no need to do that, again, when you have the ability to automate it. What is important, though, is not to overload teammates. So adjust the schedule according to your team's needs. Non-stop pull requests is, well, it may suit some teams, but there's many teams where it doesn't. And like as an example, if you have a lot of projects that share a dependency, it might be if you're in JavaScript, it might be ESLint, it might be React. And then in the middle of your workday, there is an update to ESLint or React, and you've got, automatic updates enabled. Then you might find that your build machines get slowed down, testing 50 projects for the new React version or something like that. So it is definitely good practice if you can adjust schedules according to your team's needs. And the other thing just to remember is it's pretty simple, but the more up to date you are, the less the vulnerability risk is. Like if you're really up to date, perfectly up to date, you may not even get hit by the vulnerability disclosure. But even if not, and that's still going to happen, if you are only 1 or 2 releases behind the latest release when a vulnerability patch is made, then it's going to be a lot easier for you to review and a lot low risk for you to apply that update when it happens. All right. So just to recap the dependency maturity levels, at the first step, copy and pasting third-party code. This is a very high-risk approach. Probably you'll never update it, and you may end up with vulnerabilities and bugs. So for example, if you're copying old versions of Lodash, things like that, jQuery in and never updating them, there'll be a very good chance that at some point you're going to be running vulnerable code, and that somebody looking to exploit your website will be able to detect and use that. The next level of maturity level is to use dependency ranges. If you declare dependencies with a range and you rely on semantic versioning, this is still high risk because different versions can be installed on every machine. 2 developers can have different versions, your tests can have a different version, and even worse, your production can have a different version. So at the next level up is to use log files. So using log files already reduces your risk significantly because it gives you predictable builds and dependencies that won't just automatically, update themselves, potentially introducing bugs as well. At the highest level of maturity, you've got automated dependency updates. Now, when combined with log files, this gives you the lowest risk. The reason why is because the log file prevents you from accidental upgrades, while the automation makes sure that you don't forget to upgrade. So in this case, you'll know whenever there's an update, even if you're deciding not to apply it. So even if you ignore it, you suppress it, at the very minimum, you should have like a dashboard where you can see at all times how out of date you are. And it also lets you review the release notes to encourage you to not be lazy with just applying updates without looking at them. So, getting towards the third section, what is left to do. So it actually can be quite a lot of work to continuously update dependencies. Now, depending upon what you're working on, that might seem like, completely justified. I mean, the automation itself might be saving you 80 or 90% of the time. And if your software is of high risk, then staying up to date, both for bugs and vulnerabilities, that could be completely justified. But on the other hand, the earlier you adopt a new version of any dependency, the higher the chance it has an undiscovered bug and you're the one that gets to discover it. So there is a downside to this. If you stay very up to date, then there's a much higher chance that you're one of the people who discovers the bugs rather than applies the bug fixes. All right. So the first step to improving this, well, first of all, people will say to you, you should have good test coverage. Or they'll say, I apply updates because I have good tests. And that is definitely a very good idea, right? So, I mean, if you have poor test coverage, if you don't have, for example, visual regression testing on your website, there is a good chance that you will apply updates that do break something, regression failures. So having good test coverage is excellent. It's admirable, but it's not itself enough for you to be completely sure. And the reason why is because when you write tests for your software, you're generally not, it's not your job to test all the functionality of your third-party dependencies as well. So generally when you write unit tests, even if you have 100% coverage of your code, you're unlikely to have 100% coverage of all the third-party code that might be called during your application. So your tests on their own are very important, but not foolproof. So if your tests pass with a new version, how confident are you that nothing will go wrong? So when you see your Circle CI, your Travis CI, your GitHub Actions, when you see them go green for a new dependency, are you confident enough to just apply it? Or do you want to do some manual testing, or you want to wait, or whatever? So generally speaking, most people with good tests will be pretty confident, but not completely confident. But what if I was able to tell you that tests also pass for 200 other companies using the same dependency? So this group statistics is very powerful. If I asked you to taste milk and tell me if it's going off, you have a pretty good confidence that you can detect that, but you wouldn't be 100% sure. But if 200 people also said that it's fine, you would have a very high confidence level. So this is one of the future directions of mature dependency automation and vulnerability handling, is not trying to do everything on your own, and that is to rely on the safety of the crowd. At the next step, so before we're talking about testing, but passing everybody's tests is a very good sign. If there is a new release and it basically passes everybody's tests, that's an excellent sign. However, it is still possible for bugs to slip through, especially visual tests, which are a lot harder to test. So if, say, you are not in urgent need of an update, but you want to be reasonably up to date, what if you could wait until, say, 100 companies or 20% of companies have already upgraded for a week? So, this would be another level of confidence. Not only that this release has a high level of passing, but also that a significant percentage of companies like you have already upgraded and have been running it, say for over a week. Pick it. It could be 2 days, it could be a week, could be a month. It depends upon your risk level. But this is like another level up of, having confidence levels in dependency upgrades. Even more importantly, what if you had the ability to skip any upgrade that saw multiple other users or multiple other companies roll back the new version? Because upgrading is a very positive sign, and upgrading, say for over a week, is really excellent. But a much more significant sign, and it's a negative sign, is if people roll back a dependency. Now, for me, if I was using a certain dependency in my website and I could know that a lot of users had rolled it back after upgrading, I would not want to touch that upgrade, even if I knew it passed my tests and passed a lot of others as well. So this is the next level, which is not just, aggregate test scores, but it's also about pulling together information about what others are using and using that as a metric for confidence levels in dependency updates. All right, so most of what we've discussed today, or a lot of what we discussed today in the dependency automation area, is covered by an open source tool that we have built. It's called Renovate in open source, and we are wide source. So it has over 100 contributors. It has pretty much daily releases. So if you are interested in dependency automation, please check it out. It has very wide platform support. Again, all in open source, GitHub, GitLab, Bitbucket, Azure DevOps, and actually just this week, even Gitya, self-hosted Git platform. There's over 40 package managers supported. So not just JavaScript like NPM and Yarn, not just Java, Gradle and Maven, but Python, Go, Docker. We support Kubernetes manifests, we support Helm files and things like that. And importantly, for what we talked about in the previous slides, is that there are thousands of participating users and companies from which we are gathering safe dependency data and working on schemes to benefit everybody by allowing that data to become a decision point in terms of dependency update automation. Now, Charlene, I think we've hit the last slide. We have some questions
Yes,
that have
we
been asked by
do.
the audience. Please,
Yeah.
if you have any questions, submit them now because we'll be going through them.
Yes, yes. Plenty of time for questions, guys. If you do have a question, just use that GoToWebinar control panel and submit them. And let's go ahead and start with the first question here, which is, let's see. How is the impact on custom code, which is using these dependencies? Let me just rework this sentence here. How is the impact on custom code that's using these dependencies mitigated?
Yeah, okay. So one of the challenges is that when you do update dependencies, the open source, is that it can change the behavior of your own custom code. This, though, is something that I would categorize in the area of you do still, if you want to be an early adopter or a reasonably early adopter, you are going to need to have pretty good tests. So, for example, if an upgrade of a dependency changed some of the behavior of your code, first of all, that's probably an accidental breaking change. If so, it's unlikely that a true bug fix would have done that. It is something that is best caught with your own unit tests if it is changing your own behavior. Now, on the other hand, if you find that having enough tests in order to be able to cover that, if you find that that's like a challenge, or let's say an expense that you can't manage, this is where the crowd data will become increasingly important, because if hundreds or maybe even thousands of companies have already adopted a new release, you probably and none of them have rolled back, you probably don't even need to look at your own tests. I mean, you will, but if you waited long enough that the crowd score can give you a good enough score, then that would be enough. I mean, it's not whether a dependency is kind of like has a breaking change, has a bug or not, whether it's good. It's not like movies where lots of people could like a movie, but you won't. I mean, what we're really just looking for is broken releases, because if releases never broke, we just update everything. So our goal is, what data can we use to determine breaking releases, and undeclared breaking releases, and the crowd data is a very good alternative to your own tests, and a very good supplement too.
Okay, so what about with that same question though, but when you automate the dependency upgrades? So does automation have any impact on it?
So the way it works, and actually it's good, sorry that you asked this, follow-up question, because if you haven't used the dependency automation before, just to describe it works, the dependency automation itself is not running tests. I mean, it is an integral component with, say, your, like I said, your Travis, your Circle, your GitHub Actions, your GitLab pipelines, or your Bitbucket pipelines. So essentially, these automated tools will submit a pull request to your project in the same way that a developer would. It's like if you had a developer and their only job was to check all of your third-party code for updates, and then to like submit a pull request that has all the patches applied and copy and paste the release notes. That's essentially what the tools like Renovate are doing. They're like that extra developer. So they will submit a pull request, and the pull request will then trigger your regular tests, your regular unit and regression tests. I've even oversimplified it there. It's also possible to even have a tool like Renovate just create a branch and no pull request, and to only raise pull requests, say, if it passes or if a certain amount of time has elapsed. So you do have some flexibility there in terms of how you manage those updates.
Okay, all right. Plenty of time for questions, guys. So if you have one, just go ahead and use the GoToWebinar control panel and submit it. I've got a couple more here. Which do you think is more risky, remaining on old versions or updating to new versions that might break something?
Yeah, okay. So yeah, this is back to the fire alarm approach versus, fire hose. So the fire alarm approach, don't, if it ain't broke, don't fix it. And the fire hose approach is just continuously update, non-stop updates. Now, people that may have concerns about, say, dependency automation, they will often say that, well, I mean, yes, there might be bugs in the current version, but there could also be bugs introduced in the newer version. So, maybe I should just not do anything, and naturally in life, not doing anything is often the easiest choice. I think, though, it's important to understand kind of like the statistics of it. I mean, yes, it is true that new versions may introduce bugs. That definitely can happen. However, that's the exception. That is not the rule. So if you, like it is certainly more common that new releases do not break anything, do not introduce bugs. It's definitely less common that they do. And in fact, if you stay where you are, you've kind of got a double problem. You may have bugs that are unfixed and that are impacting your users. So they may be bugs that flow through into your app. It's not always easy to determine automatically, bugs in production until your users report them. So, if the choice is between waiting for users to report the bugs versus, reading patch release notes and, knowing that there's a bug that can be fixed, you should generally go for applying the patch rather than waiting for your users to have to report it. I mean, a lot of users will never report problems anyway, even if you have an easy way to do it. So I think that the concern about, oh, if I update to a new version, it could break something. This one really is overplayed. If you take some of the advice I mentioned before, where, if you don't need a new version, don't be the first to update to it, then this is a pretty sound approach that minimizes your risk. So every time there's a new release, it's generally because of at least there's either one new feature or there's one new fix. And again, normally features or fixes are released because somebody reported them or requested them. So, let the people who need that fix or need that feature, let them take the updates first, for example, and then, be a fast follower. The risk of remaining on old versions, is pretty high. I mean, it's almost kind of guaranteed. It's guaranteed that there will be unfixed bugs. It's guaranteed that you will get vulnerabilities at some point. And it's pretty much guaranteed that you're going to have a lot of pain when you apply the vulnerability patch, because you're going to have time pressure, you're going to have stress, you're probably not going to be able to test it completely, versus if you instead adopt an automated process where you apply patches after adequate testing. So I think that maybe the only reason to take a cautious approach to updating to new versions is if you have, say, very poor tests. I mean, if you are not confident in your own tests, then that can be a reason to hold back. But even then, I would never recommend like a pure, do nothing approach. I would say just be a slow follower rather than, staying where you are.
All right.
Anybody who has good tests, especially say if it's a web site and you have visual regression testing, for example, in this case, you most likely benefit from the bug fixes because you have a lower chance of regression failures.
All right, great. Next question here. How is it possible to patch a vulnerability before it's announced?
Oh yeah, so this was from one of the earlier slides. So the claim that I made was that yeah, it is possible basically to patch a vulnerability kind of like before it exists. I mean, it really depends upon your definition of existing, because to most people, a vulnerability, first of all, a vulnerability may be there for years. We, to us in DevOps and us in Dev, on those days when you get notified of a vulnerability, it may feel like a hand grenade has been thrown into the room. There's a sudden chaos to deal with. Vulnerabilities, though, are more like an old unexploded like World War II bomb or something, because often vulnerabilities have been there a long time, and it's just they only just got discovered, right? So vulnerabilities are often been there a while, then they are fixed, and then they are announced. So the concept is that if in most cases the bad guys only find out about vulnerabilities when they're announced, sometimes people have exploited them before they've been announced. But if the bad guys find out when they're announced, then it is possible for you to basically patch it before they find out, if you have a regular patching approach. So the idea is that you're essentially I was going to say exploiting, but that's a bad term here. You are relying on the fact that there is nearly always a window between the fix and the announcement. So if you have a process for applying fixes early, especially when they're a patch rather than a minor, then you often may get ahead of the announcement itself. So that's a justification for saying that dependency automation can actually, patch a vulnerability before it's announced.
Okay, that makes a lot of sense, actually. Okay, got another question here. Why not implement your dependencies as a contained service library approach? The apps can then version the service that they want in the request. That allows apps which share common services to choose which dependency they can use. All they would then need to do is change the version dependency request in the RPC. Is that approach used? And some apps we know cannot upgrade easily.
Yeah, so this is a good question. This comes from Tim. So it is true. Like I shouldn't downplay the fact that some apps can't be upgraded easily. But there is a saying where they say the best time to plant a tree is 20 years ago. The second best time to plant a tree is now. And it can be a little bit like that with dependencies. The reason for most apps that they cannot upgrade easily is because nobody upgraded them for weeks, months, or years. So it's kind of like a special category, and it is okay to differentiate between your legacy apps that are very hard to update because they've gone so far behind, versus the apps that you are more recently updating that you can apply automation to. It's pretty rare that an app is released and a day later it couldn't be upgraded easily, and similarly, a week later or a month later it couldn't be upgraded easily. I mean, in most cases, the reason they can't be upgraded easily is just that there have been breaking changes since the last time that they were done. So then the question here was, why not implement your dependencies as a contained service library approach? apps can then use the version, the service that they want in the request. So yeah, look, we've also seen companies try to do this where there'll be essentially like a central pool of consistent versions. I mean, this can be good just on its own to apply consistency across projects. Yeah, the challenges is still that, you know, if that service has versions of libraries that are vulnerable, you still come back to the same problem. It may even be like a harder problem because one change to the central service then could impact 50 different projects. And you know, if it's a large change rather than a small one, it could actually hold you up from, you know, patching, you know, 45 of the 50 that have no problem because 5 of them, you know, are difficult.
All right, great. Okay, we are about 9 minutes to the top of the hour. I think we have time for one or two more. Okay, here's one. Should I use lock files for applications only or libraries too?
Okay, yeah, so I mentioned lock files. There's a bit of debate here because if you write a library and you know you lock the dependencies or you freeze them, then it means when you're developing locally and testing against it, um, then sorry, I just spilled water. When you
Oh no.
when you're developing locally, you'll get like a limited. All right, recovered. Um, you'll get a restricted number. Whereas when people use your library, they will then be using the very latest. And so what your end users receive is different to what you use. Um, so it's a valid point, but at the same time, it's also very good that everyone working in a team, whether that's a library team or an application team, that everybody working in the team gets the same dependencies installed at runtime. So my advice is to use a lock file combined with dependency automation.
Okay. All right, great. I think we have time for one more question here. We are already using Renovate. How do you configure Renovate to be a quote unquote slow follow adopter instead of updating to the latest with frequent pull requests?
Okay, great. Well, okay. Well, first of all, thanks, Zach, for using Renovate. So the question is, you know, related to the last few slides about being a slow follower instead of instant. Okay, so you know, a simple way to slow down is to use scheduling, like every week, but that itself doesn't solve that fundamental problem that you know, if Renovate raises a pull request on a Sunday, that it could be including a dependency that just got released that day. There are settings in Renovate that allow you to specify essentially like a delay in adopting dependencies. So one of those, the earliest one we introduced was one we called like an unpublish window, because there was a period where multiple libraries or releases were getting unpublished off NPM after they were released. So if you were, it got released on a Saturday, you adopted it on a Sunday, it could disappear on a Monday and it breaks everybody because you're locked to it. We've since added a more generic approach for all. Actually, I forget the setting name, but you know, please post in our config help. But there is the ability to specify a number of hours or days of maturity of a package before it is stability days. That's it, stability days. And in fact, we use this on the Renovate project. So we've specified a three-day stability day restriction. And what that means is that within the first 3 days after a new version is released, that we will not get a pull request for it until it's past 3 days stability. I do recommend, though, that you use that in conjunction with the Renovate dashboard. We call it master issue, because the master issue lets you, even if you're holding back dependency updates due to scheduling or due to stability, it gives you a view of all the updates that are pending. So that if there is a new version that's only a day or two old, but you really want it, you can just tick a box and the pull request will be raised regardless of your, of your general setting. But anyway, feel free to jump into our config help repository and ask for help with that.
Okay, great. All right, so we are about 5 minutes to the top of the hour. So at this point, I'm going to go ahead and close out the question and answer period. Thank you to everybody who did submit questions, really good ones. So thanks again for that. Do want to quickly remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to listen to it again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go find it there. Just go to devops.com/webinar, look in the on-demand section, and it should be right there waiting for you. So before we close out the webinar, I did at the top of the hour let you guys know that we would be doing a drawing for 3 $50 Amazon gift cards. So without further ado, we'll go ahead and do that now. Our first winner is Zach W. Congratulations, Zach. Our next winner is Edward C. Congratulations, Edward. And our final winner today is Brian E. Congratulations, Brian. And we'll be reaching out to all three of you via email after today's webinar to make arrangements to get the Amazon gift card over to you. So look in your email for that. I guess that's about it for today's webinar. Rhys, thanks so much for giving such a great presentation. Good stuff. Really like it.
Thanks, everyone.
Yes, thank you. And also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.